Welcome to a lesson with Dr. Powell. Let's take a look at how we can convert from spherical coordinates to Cartesian. Now, we're going to use a little triangle here, has rho as a hypotenuse, r as an adjacent, and z as the opposite, and there's phi. So we can see this very nicely if we just kind of make an intermediate step as we go from here to here. And then intermediate step is cylindrical coordinates, which is r, theta, and z. You see this r and the z, and this rho and this phi, these all go together in a triangle. This, and notice how it's the ends, so this one and that one and that one and that one. The r and the z are the legs, and the rho, the one where that has the angle associated with it right here, is the hypotenuse. Now z is vertical, and so it's going to be the opposite. It's the vertical part. R is going to be the adjacent part. So based off of this triangle, we can easily do the conversion. For instance, what if we have something like 2 and maybe like pi thirds and negative pi fourths? How is this going to work? So we have two angles here and we have that. Well, let's kind of remember here. So what's going to be important to us as we do this conversion? Let's do this in steps. So first, why don't we try to convert it to polar coordinates and an altitude? So polar in here, so that would be cylindrical coordinates. So we want an r and a theta instead of a rho, theta, and a phi. The nice thing about this is that the phi always stays the same. Pi thirds. Okay, so what we need now is we need an r value and we need a z value. Now look, r and z, they're legs of this triangle that has this and that phi. So we have a triangle with 2, and actually negative pi fourths, the triangle really should be facing the other way, but I'll just draw it this way, at least to get the idea. So 2, we have our angle, and then we have z opposite and r right here. So we just need to figure out this z and r. Okay, so what we could do is we could just take, if this were a 1, the z would be the sign, but since it's a 2, we just multiply it by 2. So this is actually equal to 2 times the sine of negative pi fourths. This is equal to 2 times the cosine of negative pi fourths. So, and so we're going, and that's z. So z is going to be negative, but this one is going to be, the r value is going to be positive. Here, cosine of negative pi fourths is a positive x value. And we're going to get, looks like we're going to get negative root 2 and positive root 2, because that's root 2 over 2, but the 2's cancel. And this one is negative and that one's positive. Okay, so we successfully convert it to cylindrical. Notice how we do this in stages. We move from spherical to cylindrical, and we can do that using this triangle right here. Now, actually, to make the next step, there's a very similar triangle. Let's think for a minute. We're dealing with x. We want to find an x value and a y value, and our z value we've already obtained. So that's the same. So really, we're just looking for x and y. Notice that all of these actually are in a triangle. Analogously to what we had over here. See the guy right here that's with the angle? That's hypotenuse. There's your angle. You see right here what's further to the right? That's opposite. Just like the z is further to the right, that was opposite. and then the one further to the left is adjacent. It's the same thing. So here we have a triangle with a y value, an x value, the hypotenuse, and the angle, which we could have known anyway just by thinking about polar coordinates. But I just wanted to illustrate how it really is the same kind of relationship between the pairs, the triples, the ordered triples, that is, not pairs. Okay, so so to figure this out, y in this case would be square root of 2 times the sine of pi thirds. So maybe right here. So y is equal to square root of 2 times the sine of pi thirds. And x is going to be square root of 2 times the cosine of pi thirds. So the sine of pi thirds is kind of a bigger angle. So the sine, that's going to get the bigger y value. So that's square root of 3 over 2 right here. So square root of 3 over 2 times root 2. Now, root 2 and 2 is like root 2 times root 2. So one of those would cancel. So we're just going to get the square root of 3 halves, if you like, here for this particular case, if you work it out. Square root of 3 halves. Now, cosine of pi thirds is going to be the smaller angle. So it's going to be this is going to be 1/2. And 1/2, so square root of 2 over 2 is, yeah, we could just keep it at that if you want. That's fine. There's ways we can work with that, but that's fine. And I guess you could rationalize this, but honestly, I like that form. That looks fine to me. So we have y is square root of 3 over 2, and x is square root of 2 over 2. And so we've been successful. We just put those in and we've successfully changed our form. So the final result is going to be square root of 2 over 2, square root of quantity 3 over 2, and negative root 2. We have just successfully converted these spherical coordinates into Cartesian coordinates. And let's kind of think about this to make sure this makes sense. Phi, let's think about what phi means. Phi is an angle that goes from the xy plane, either up or down. Notice that it's going down because it's negative. So if we have x, y, and z, so we're going to be going down. We're going to be down below the xy plane is what that means, going at an angle of negative pi force. In this direction, we go an angle of, like there, of pi thirds. Over here, we're going down an angle of negative pi force. And it looks like we're going to be 2 away. So we're going to be 2 away there. So we're kind of going to be down right here. And let's see if that makes sense. So we have coordinates here to give us this point, and then we're down there below that much. So it looks like we're pretty accurate. Let's double check a couple things. Why don't we double check the length of this as a vector from the origin just by taking square roots, or taking squares, and then adding those and taking a square root and seeing if we get 2. Let's see if that is actually accurate. So if we square this, we're going to get 2 over 4, so that'd be 1/2. This one would be 3 halves. And this one we square it would be 2. Oh, it looks accurate because this is 2 plus 2, that's 4, and square root of 4 is 2. So it looks pretty accurate. The length here is exactly what we want. So we can probably just say, yeah, with all the other steps we did, we probably did it the right way, and there we go. So we have converted it from spherical into Cartesian. Thanks for watching.